Okay. Hello, everyone. Let's get going. Please take a seat. Okay, please take a seat, including that includes the chair.
There's a reason why it's called chair.
Yeah. Okay. Welcome, everyone. This is the third session of OAUTH work group. And you might notice there is a different background here. So there is some ongoing competition right now. Look at this view. Hannes, do you want to talk about this?
This is an attempt from amateur photographers to compete with Brian. You're safe, Brian. Yeah.
Do you want to say anything to the mic?
It is a really nice photo, and our responsible AD told me you took it while you were out with a run with her in the morning, and I encouraged her to encourage you to include it in the presentation. I love the tradition. Thanks for sharing.
I thought you would say that you encouraged me to take a real camera with me while I go running.
I would like to see that.
Okay. This is the not well. I'm gonna linger a little bit on this one because our legal teams are asking us to kind of talk about this a little bit more. So, yeah, we had a chairs meeting, and they want us to talk a little bit about this more. Anyway, so this is the not well. This applies here, as you know. I'm sure you're sick and tired of seeing this, but it's important. This governs everything that we do at the IETF, including IPRs, if you have any concerns about that, your privacy details about your information, our conduct, if there is any abusive behavior, whatever. So if you're not familiar with this, please take a look and make sure you're familiar with this. Okay, tips. Again, please make sure to scan the QR code so we know you are here and you're able to use that to join the queue. And if you're remote, please make sure you're muted and unless you want to speak up. Okay, let's skip to today's agenda. So we have Paul and team will be talking about attestation-based client authentication and token status list. We had some internal meetings to talk about those, but we'll hopefully hear the latest on those documents. Aaron will be talking about FedCM profile for OAuth. Aaron, I think he's going to be remote, unfortunately, this time. Richard will be talking about PICA. And David will wrap it up with the two kind of new topics, Alzheimer's profile of OAuth and the Alpha Authorization Policy language. So that's our agenda. Any questions, comments? If not, let's get going. Oh, yes, we have two. Yes, okay. George, yeah, and Heather, thank you for taking notes. Okay, Paul, Chris, Tobias. It is, Tobias, it is. I just handed you the reins. Go for it. Or do you want to drive from here?
Cool, thank you. All right, so this is a bit of an update on OAuth 2 attestation-based client auth. So starting off with a bit of a refresher, if I can get this to work. Is that updating on your side, Rafat?
Say it again.
Is that updating? Just checking that the slide.
Yeah, you should be able to move it around. If not, I can move it from here.
No, that's okay. Are we on slide 2? I'm just checking if my end's update.
Yeah, we can see slide number 2.
Okay, cool. All right. So a bit of a refresher. So this draft really, in the classical sort of OAuth security model, generally the client, when we're conducting client authentication, it's generally happening through a back channel, and this draft is namely sort of focusing on a client authentication method that can provide an attestation back to a front channel based client, such as a native application or a web application, through a key attestation scheme that can then allow that front channel based application or client to then authenticate itself directly with an authorization server. The main reasons for this are often privacy related reasons, especially in credential issuance, where there is a desire in deployments to not have the transaction transact through the back end of the client. So with that, I will move on. So this is the architecture that we have shown that hasn't changed since the initial creation of the draft. Generally, the client instance will generate an attestation-based key. It will then perform a protocol, which is steps 2 and 4, which the steps of 2 and 4 are out of scope for this draft, the actual protocol. What is in scope instead is the syntax and structure of the generated attestation that is generated in 3, and the syntax and structure of the attestation proof of possession, or POP, that is generated in 5, along with the interaction or the interface that the authorization server uses between the client instance and the authorization server in step 6, such as authentication at the token endpoint or various other OAuth 2 related endpoints. And so generally, there is 2 signed JOTs involved here. We have a client attestation and a client attestation POP. The client attestation signs over the client attestation key, authenticating it, and then the proof of possession is a fresh proof of possession generated by the client instance, where both are sent to the authorization server to authenticate the client instance in its interaction to the client. Okay, so changes since IETF 119, we've published 2 new revisions, draft 2 and draft 3. Draft 2 was a small, simple change. I'm just going to move on to that, which is we added some text on the inability to rotate the client instance key. So this is generally just calling out that because within one client ID, we would have many client deployments, and those individual instances, we need to be able to, when we're issuing, say, a refresh token, be able to ensure that that refresh token can only be exercised by that instance, and the way that that instance is identified in a given transaction with a refresh token is through that instance key. That it basically means that in order for the client instance to rotate the key, it would have to start a new transaction and get a new refresh token, because that is what's used for continuity in the transaction. I'm just checking there's no one in the queue on that. Okay, cool. Changes in draft 3. So based on feedback at IETF 119, we have removed the usage of RFC 7521. So we have, and we've also shifted from that syntax defined in RFC 7521 for conveying the assertion across to more of a header-based syntax, introducing 2 new HTTP headers. One is OAuth client attestation, and the other is OAuth client attestation POP, with the syntax being somewhat akin to how DPOP conveys proof of possession and JWTs in headers. And we also firmed up some of the language around the notion of a client instance and the terminology, and improved text around that concept to make that a little bit clearer. So this is the previous token request. As discussed on the previous slide, it was prior to the changes we've made based on RFC 7521, we were using the parameters of client assertion type and client assertion defined by that RFC to convey this attestation and the attestation POP. However, we've now shifted to a model on the next slide that uses header-based syntax. So we have moved to this syntax, which allows us to convey this attestation and attestation POP more easily in other endpoints to the authorization server, not just the token endpoint or endpoints that support RFC 7521. And yeah, so this is the main significant change we've made. And with that, I think I will hand over to Paul. Have you got slide control, Paul, or would you like me to?
I don't have. If you can do that, it'll be fine.
Yep.
I also wanted to add the header-based syntax gets rid of some squigglies, as some OAuth members like to say. Just joking on this one. Okay, so next I will talk about the current discussions that we have. So the next topics for this, for the iterations of this draft. One is the depop optimization, which was delayed, or where the move to the header-based syntax was kind of a prerequisite. So the motivation for this is that for a lot of use cases where we envision attestation-based client authentication, we assume that we want a high level of assurance for our use cases. So usually when we have this, we also want to protect our access tokens. And yeah, the most common way that this is done today is depop. So we get into a situation where we could actually have some benefits where we could say, well, we know which kind of key is used for depop because we get some information over the client attestation. And maybe we can do some optimizations where we use the same key both for depop and the client attestation. And it would be nice if we could combine this and just have a single proof of possession, because otherwise we will have two proof of possessions, one for depop and one for the client authentication with the same key. Given we're using this in high assurance scenarios, this might be a hardware key or a key in a cloud HSM. So doing this operation is kind of costly. So there was a lot of discussions if we can optimize the combination with depop, which can be seen on the next slide. Tobias, can you move on the next page? Thanks. So yeah, instead of having the OAuth client attestation POP header, instead we have here the depop header, and the ruling could be somehow along the lines of, well, you've got to check if there's like an OAuth client attestation POP header. If that's not present and there is a depop header for a proof of possession, then please use this one. So this is something that's being discussed. There's some people that really like this, some people that really don't like this. I think we still need some more input in this and some more lively discussions, and I think this will be the next big discussion for this draft. Beside that, we have another lively discussion that has been ongoing for some. Yeah.
Do you want to take questions or opinions on this one before you move on? Or anybody has any thoughts about this?
Yeah, I think generally, Rafat, what we're looking for is that. So just to explain the trade-off here as well, when we use this client authentication method with Depop, without this optimization, we'll end up with 3 JOTs basically in the HTTP request, and 2 of those are proofs of possession. That we would contest that in many common use cases, the key that is being used for the proof of possession could be the same. So those proofs of possession are in fact somewhat identical, right? And so the proposed optimization is that if you are using Depop and you're using this client attestation-based authentication method, that you could drop the OAuth client attestation POP and just have a Depop, right? So we're not saying that this is the only syntax that becomes valid, but is this a valid optimization, and do we want that conditionality when Depop is present, or is that a code path that implementations don't think would be useful?
Yeah, thanks for the clarification. I think Peter has some thoughts on this.
At the risk of repeating myself, I feel like this is potentially dangerous behavior, right? Where we're using a key that is meant to do attestation authentication, and then we also use it for this other proof of possession thing. I think there's plenty of examples of how this kind of thing has gone wrong in the past. And so I once again want to, at the risk of being repetitive, say, I haven't seen any reason why this is not a risk, and I haven't heard any arguments apart from there's an efficiency gain. So.
Okay, thanks, Peter. Brian.
I've been a long-time proponent of only using the Depop header for proof of possession. I understand there's desires on both sides, but I do think this is a very reasonable compromise as far as compromises go. No one will really like it, but actually I think it's reasonable. And at the risk of repeating myself, I think Peter is just sort of fear-mongering on this one. I cannot see any real way that it could go so terribly wrong. Maybe I'm not imaginative enough, but it is also optional. So those that don't want to make the horrible mistake that Peter's saying they would make aren't required to, because we're making it optional. This seems very reasonable to me, so I would be in favor of it.
Do we have some security proofs? Like, it would be like coming out of the TLS meeting, for every small change you need to have a security proof, and we basically decide things based on gut feeling and kind of looks nice, mood of the day. Doesn't sound right to me, actually.
No, but we don't have that kind of proof coming on any of our work, so I think we just don't. So to try to ask for it is just not.
Rifat and I can ask people to do that. Yeah.
You could.
Go ahead, Christina.
I don't know, this IETF, I just realized how short I am. So I think previously the pushback to this optimization has been to the idea that this is the only way to pass a POP for OS client attestation. But as an optimization, I think I kind of changed my mind, but I think as an optimization, as an option, it does make sense and does simplify things for deployments where like Depop and the POP or client attestation is needed. And now to the previous conversation on and comments on security. So we don't have this, like official, threat, official, like, I don't know, how did you call it? Like the whole peer-reviewed paper or anything, but within the German Wallet project, we did invest a lot of time in analyzing the sequence diagrams and the key management. What happens if this key is an HSM, this key is locally, and if you look at the German architecture diagram, which is open source, we do have the amount of keys involved in all this is actually fascinating, backend, instance, and all that. And I think the outcome of that is, and it wasn't just as usual suspects, but folks from ISAC and some other BSI, German security agency being involved, and I don't think we've heard like huge security concerns regarding this optimization. So yeah, obviously it's not like peer-reviewed paper or anything, but I think it's something a little bit more than just a gut feeling that this actually might be okay as an optimization.
Could you post something to the
Yes.
chat or to
Yeah.
the mailing list or
Yeah.
whatever?
Yes.
Thank you.
Awesome. Philip.
This is amazing because I get to concur to the 3 different people that talked before me. I do like the optimization. What I do fear, however, is because of the potential amount of keys involved, the fact that it is optional for use may trigger or may cause issues in implementation. So is it possible, and I mean, gouging consensus here, if Depop is used and OAuth client attestation is used, make this a required pairing so that you don't end up in a scenario where I have to create an implementation that handles 2, 3, 4 different cases.
Okay. Thanks, Philip. Justin.
Justin Richer, I agree with a lot of the points that were previously made here in different ways. I'm with Peter in that it feels like this could go sideways, but I also don't have a specific thing in mind for it to go sideways. From an architectural standpoint, I like the optimization. I like the cleanliness of saying if you have one key, do it in one place, because that type of simplicity also leads to better security and better implementations, which is a bit of what I think Philip was getting at. So I think what our best way forward might be to do would be to put this in and immediately begin writing security considerations of the ways that it could go wrong if you use it. That way, if it does end up being a really bad and insecure idea, then we'll at least have documented it and told people when not to use it and why. Kind of like we did with the implicit flow and resource owner password flow in OAuth 2, and that worked out great.
Well, that was not a good example.
John.
Now I'm feeling short. So I like the optimization. I agree that with Philip that we should probably reduce some of the optionality by saying that if you're going to combine the two, this is the way to do it. I can also see on the, I understand that you may not be able to specifically optimize having 2 different keys for this, but on the other hand, it might actually be better from the perspective of saying, look, you should use a key which has a single sort of security property for both things, because if you have 2 keys that are 2 different security properties, then the attacker goes for the lowest bar. So by having multiple keys, you may be insinuating that you have security that you don't. So the fact that you're securing both 2 different legs with the same key, which has the same security property and storage, is attractive, and I'm always in favor of doing fewer signatures because that causes problems on its own.
Tobias and Paul, when you do the key attestation, that key presumably resides in some hardware security module. If you do the Depop, would that key also be in that hardware security module, or would that be elsewhere? Because that's not attested, right?
It certainly could be, right? And I think that's where the expense comes from, and the desire, I guess, to do less signatures if possible, right? Because if that key were to reside in hardware and there is an expense involved, then that's another reason to have just one signature instead of two.
Yeah, and you get the assurance on top what kind of value the Depop key has, which you don't have with vanilla Depop.
Right.
ahead, John.
Back to my point,
Yeah.
having a much weaker Depop key than the authentication attestation key may lead to people mistakenly having lower security.
Yeah, and that's kind of a point I think here, John, right? Is tying these two keys together in a lot of these interactions so they have an equivalent security means you get better consistency around the client security, client instance security across the transaction.
I think that the general guidance of you have a key which has security properties which the issuer needs to know about, or the OAuth server needs to know about, you kind of want the same security level for all of your proof of possession interactions. If you start mixing them,
Yeah.
that's harder to explain, harder to reason about.
Okay. Thanks, John. Philip, quickly, we're running out of time here.
Yes, very quickly. So what I'm hearing maybe is that I don't see why we should support the optionality. You know, if you use Depop and this together, this is the way.
It's I think it's not that easy, because one of the motivations that we moved to the header-based syntax was that we don't only want to use this with the authorization server, but people explicitly asked if we could use this at other endpoints, and other endpoints can't have Depop or are maybe less likely to.
Okay, so what I meant is if you're using Depop and this together, then this is the way,
Okay.
not the other syntax. And yes, using this for other endpoints such as at the resource server, this is perfectly fine, and that's why we moved away from the body-based syntax, which JSON-based APIs cannot support.
Okay, Brian, go ahead very quickly though, and Paul and Tobias, we're gonna quickly switch to the other presentation.
I'll try to be quick. So I kind of agree with Philip, but it has been told to me several times when I've been arguing that point that there are real world use cases of wallets for which the computational use of a particular key is both expensive and very important for the attestation. And at the same time, they want to be able to do Depop separately with a less expensive and less secure key. But when I've been pushing for this, I've been told that that's an important use case. So that's part of why it's developing this way. So
we should definitely double check that, whether that's still true today. That's a good point.
Yeah, and I'll just briefly mention the other discussions. One is the naming discussion, because some people, especially from the Reds community, don't like the attestation term, and the other one is about a nonce fetching. But yeah, due to time, let's not go into this topic.
Okay. Do you have too many slides after this, or do you want to briefly talk about those and then switch to the other presentation? Do you need the full 20 minutes on the other presentation?
Not sure. Yeah, I think there's not that much about status list. I think it's fairly. Let's spend 1 minute on the other two discussion points.
Okay.
Tobias, can you move to the next slide? Yeah, as I mentioned, the first one is the naming discussion. Just make it very short. Torsten had one proposal that says key-bound job client authentication. Is there are any opinions on this? There's an issue on this, or just cry out loud now?
But you are doing key attestation in the document, like calling it authentication would be like.
It's both attestation and it's both key bound.
Right. Yeah.
Ori, do you want to state your proposal here?
Hi, Ori Steele. As the author of another draft that also used the word attestation incorrectly, or not incorrectly, but whatever, just use assertion for most of the cases where you get this sort of pushback. Assertion seems like it can be a better option sometimes.
But in this case, it's really attestation.
I can't answer that. But
Okay.
but if the RATS people are saying it's not, like, you can continue. I think it's there. I would talk with them about that.
Okay. Yeah.
John. And then let's close this.
Geez, naming has come up, conflicts has come up a couple of times, hasn't it? I guess the RATS didn't invent attestation. Attestation is used a term used lots of places for lots of things. I think we can ask the area director, perhaps, to say, come up with a determination of whether or not it's okay for us to have a different attestation format. I don't know whether there's an expectation that all attestations go through that particular work group. I have a really hard time seeing that they can completely squat on a generic term.
I don't think RATS is doing that. RATS tries to be kind of helpful with the terminology, and because it's used in so many different ways, like having consistent terminology, as we all know, also in the identity space, is really important if we have the same properties. Of course, if it's different properties, then we shouldn't use this name, right? That's the key point. But I'll hand it over to Kathleen.
Kathleen Moriarty, one of the 3 RATS chairs. I don't think necessarily the problem is your use of it, unless somebody has said that explicitly. I think it's that we all wish we could backtrack and never have used the word attestation. And the reason is because if you say it outside of these circles, people are so utterly confused and they only think about paper or processes that result in a paper report that says this is an attestation tied to an auditor process. I am finding this. Well, so I can tell you 20 so years ago, I did an attestation against the certificate authority that I managed, and it was to attest that the practices, the operational practices matched the practices statement, and the practices statement was aligned to the policy, right? And so it's this auditor process that people assume with the word attestation. So I think if we're able to use it in RATS, you should be able to use it, but be warned, it's confusing.
Okay, I think there is probably more work to be done on discussion, but Hannes and I will kind of take it offline and talk maybe with the RATS team and see how proceed here. Okay, thank you all. Paul and Tobias, do you want to discuss the last one quickly? But you're not.
Let's move to status
You're not going to
list.
have too much time for the other one, bro.
Yeah, let's move to status list.
You want to? Okay, switch.
Status list.
You can switch from your side, right?
No. Yeah. So I don't have a screen control, unfortunately. Do you still have it, Tobias, or how does it work?
Yeah, I do. So just
Yeah.
tell me when to change.
Yeah, okay. Let's go through it. Token status list. It was formerly called JOT status list. It's a revocation or status mechanism. We have tokens or credentials or whatever we issue, and maybe the semantics about this change, and we want to communicate this afterwards, and therefore we have a revocation or a status mechanism so that we can convey this afterwards. Here's an example of the entities involved. So usually we have something this we call an issuer, and he issues a referenced token. This can be an access token. This can be a verifiable credential. This can be anything. So we don't make any assumptions on this. This can be communicated to a client, but it can also be directly communicated to a relying party. And then the relying party has the possibility from within this reference token to get information about the status. And in our case of the status list, he has then the ability to fetch a status list, and this status list is provided by the issuer himself or by a status list provider. And by this means, he can get information about the status of the reference token. Next slide. So how does this work in particular? Here's a JSON example of a reference token in form of a JOT. We have a new claim that reaches that is the status claim, and at the same point, this is the extension point for other status mechanisms, as we have the status assertions that was presented on Tuesday. So we register a subclaim under status, which is status list. If you see status list, then you know this is a status list according to this draft. If you see other parameter names, then you could look up in the IANA registry, and then we have a pointer to different draft. The status list parameter then contains an object with two members. The first is the URI, which points to the URI where the status list is hosted. And then IDX communicates the index within this list where the status for this particular reference token is available. Next slide. So how does this status list, if we fetch this URI, then look like? There's two possible ways to communicate this. One is a JOT, one is a COT. And yeah, there's some validity information and some JSON Web Token usual stuff. The most important one is the status list property member parameter, and it has two parameters. One is bits. This communicates how many bits are used to communicate the status of one reference token. So if this is one, this means there's one bit for each reference token, which means it's either valid or invalid, but that could also contain more than one bit. And then LST is the list of the status list. And in this case, this is base 64 encoded and deflated status list byte array. Next slide. We can then see how this looks like. So this is a byte array, or we call it byte array instead of bit string for certain reasons I don't want to go into here at this point. But you can see, so from the top one is the reference token, the URI then matches to the lower black box, which has the status list, and then you deflate the list, and then you look at the specific index, and then you know the status of the reference token. This is how it works. And then handing over to Christian.
Yeah, and looking at the time, we need to be a bit fast to have a bit of time for discussion. So changes since Brisbane. Next slide, please. A lot of editorial changes, fixes with like stuff we did before. Two big ones. That is validation rules for status list token and a status list aggregation mechanism. Next slide, please. So the first one, we did the first shot at the validation rules, which was also like a good thing for us to figure out how easy is it to write it down. And we realized we have some problems with complexity because of the different options. So right now we have CBORD, JSON, JOT, and CWT encoding, and that makes actually writing validation rules pretty complex. So we would like to make that easier. We would like to simplify the draft a bit, and of course feedback is welcome. Next slide, please. Status list aggregation mechanism. If you have ideas for a better name, please go ahead. So this is basically the idea to enable a relying party to do caching. So beforehand, if you know you are gonna get tokens of a specific issuer or OAuth server, then this enables you to beforehand basically cache status lists. And this is just a mechanism which basically gives you a list of these other status lists that are relevant for that party. We have two modes to retrieve this. One is basically it could be embedded in the status list token. So this is basically as part of this spec. And the other one that we foresee is that it can be provided out of band with basically additional metadata of the issuer. So for example, with OpenID for VCI or similar methods. Next slide, please. Okay, discussion. This came up a few times already, especially after writing the validation rules. We are considering again removing the unsigned option because basically all implementations so far are using the signed option. We would like to simplify. The other option we were thinking about is alg equals none, but we're pretty sure this is going to be not liked. So Brian is already in the queue, I guess.
I would argue that the only option you support is the unsigned option. That would simplify a lot of things. And the perceived needs around having this thing signed, I think, are somewhat misguided. The one real use case I've understood for it is something akin to the draft that was presented the other day, which is like a stapling type approach, of which there are other ways to do it. When you're doing this as a verifier, there's really no read to sign it. And if you do want to have more than one options, there's now a whole working group spun up for the CBOR-based digital credentials. So you could punt that stuff. At least if you demand a signed option, you could slide that out over into the other working group. But it'd be better just not to sign them all, sign it at all. So I can see I'm being laughed at, and I appreciate that because I know it's in good humor.
Okay, we're running out of time, so Roy, go ahead.
Roy Williams, Microsoft. Christian, is there still a time to live to control the cache lifetime?
Yes.
Thank you.
Jeff.
Yeah, Jeff, very quick. So it sounds like now there are like multiple identifiers. There is like the index into the list. There is the GTI. I think it might be complex. I'm coming from the PKI, CRL, OCSP world. That sounds like very complex. And if I'm thinking from the aggregator perspective, now if I want to aggregate an entry that has an index of 1 into one list, 5 and 10, I need a very large entry that will have a lot of values that means nothing because I'm just referencing those different index along the way. So that sounds very complex. And just to like re-emphasize what Brian said, so far, everything was onto the JSON world and then a translator to make it to the CBOR world. Here you are trying to solve the both side of the equation in one single RFC, and maybe that's where the complexity is coming from.
Okay. Thanks. Richard.
Richard Barnes, PCA co-author. I was just responding to what Brian Campbell was saying about signing this, and so just wanted to get up and say we should absolutely sign these for the same reasons we signed PCA to avoid runtime dependency, verify time dependencies on HTTP servers. I don't know about all you like wealthy people with 5G connections and whatnot, but like a lot of the world is not connected. All, yeah, absolutely. I mean, even you know, my American in-laws are out in the country and don't have Wi-Fi all the time. Sometimes I need to authenticate to get in the house. So yeah, let's avoid those runtime dependencies.
Thanks, Richard. Christina, do you have a quick comment? You were in the queue there. Okay. Thanks, Christina. Okay. We are out of time for this one. Tobias and Paul and Christian, thank you very much. And yeah, let's continue the discussion on the list, right?
We have one more important slide for the timeline that we envision.
Okay, go ahead.
You move to the last one. Yeah, Outlook. So our plan was we feel that there's not that many major issues that are being discussed. So our intention is for next IETF to have the draft ready to get to working group last call. It's our intention. We know there's been some discussion about whether this needs to merge with status assertions or not. We are all three convinced that we do not want to do this because this standard is pretty far and is required by a lot of people and will add a lot of confusion if we merge this with status assertion. So this is not our intention, and in contrast, is our intention to kind of get this draft ready and done.
Okay, awesome. Thank you all. Appreciate that. Okay. Okay, next. Aaron?
Yes, hello. Can I get the slide control? Great. All right, here's a picture of Vancouver from before I had to leave and go home. It was nice to see everybody. So today I'm going to talk about FedCM, in particular the FedCM profile for OAuth, which I've been working on. I do not have a draft that to read, so pay attention to the slides. The reason I don't have a draft, we'll get into in a little bit. I'm going to quickly give a recap about what FedCM is and the problem it's trying to solve. But I'm not going to go too deep into this because we already had a presentation on this at the interim. But I do just want to quickly recap this to set the stage. The problem is that there are a lot of different ways to track users around the web and using various technologies. The two we're focusing on here are link decoration and third-party cookies, specifically because those actually end up having a lot in common with OAuth and OpenID Connect. So third-party cookies is when you have a website that's embedded or some sort of content from another domain embedded on one domain, and the cookies get sent along from that website get sent along to it, which means that if two different websites have the same page embedded, the two different websites can actually end up tracking the user and knowing who the user is in common. Unfortunately, this is also how some OpenID Connect features work. So in particular, front channel logout, you have the identity provider, which embeds iframes from different relying parties, relying on the fact that, no pun intended, relying on the fact that those cookies for the identity provider will be, or for the relying parties will be included in the requests. And the opposite is also true when a client or a relying party embeds an iframe from an identity provider. It is also relying on the fact that that cookie for the identity provider will be sent in the request from the iframe. In other news, link decoration is another way that users can be tracked. For example, example.com wants to use a tracking website to figure out who a user is and connect them when they visit a different website. They can send the user through a tracking website, which all of these cookies in this case are first-party cookies, but because we can use query parameters, we can actually end up building a common user profile across all the different websites. This is, unfortunately, how OAuth and OpenID Connect and SAML work. So we have clients that do redirects through authorization servers that might redirect to another identity provider, et cetera, and back. These query parameters that are used in our protocols are effectively tracking the user because that's what they're designed to do. They're designed to link the user between the client and the authorization server. So all of essentially it means that they look like trackers, especially when we're talking about multi-hop federations that might send the user through 3 or 4 different hops before getting back to the RP. So the FedCM, well, in particular, the working group, Federate Identity Working Group and Community Group are created at the W3C to solve this problem, to basically allow federated identity flows to work without relying on features that can also be used to track users. The community group was formed a few years ago. This is open to anybody. You can join you can just join the community group at the W3C. The working group was formed last month, and that is limited to W3C member companies. So there are currently 2 proposals for this in the working group. One is FedCM, one is cross-site cookie access credential. I'm going to go briefly into how these work. and then talk about how we can use them in OAuth. So FedCM, it's a browser API that manages identity flows on the web, and the important part is that nothing is disclosed between the RP and IDP until the user allows it. So essentially, the way this goes is the user starts at the RP or the client. I'm going to use these terms interchangeably because even though they're from OAuth and Open Connect, that RP will initiate the API, which causes the user to see a prompt, agrees to log in, and then importantly, the browser, not the client, starts making requests to the IDP endpoints and eventually gets data from the IDP to return to the client. So this is what it looks like, but let's go through the flows. Let's go through a couple of the requests. I'm not going to go too deep into this, but this is important in order to figure out how we're going to insert OAuth into this. So this is the client code that that would be in a RP, JavaScript code. It's a JavaScript API. It'll say, hey, I'm trying to use this authorization server. Here's the client ID. We'll come back to that params in a minute. At this point, the client, it doesn't see anything that's happening, and the browser takes over, and the browser starts making requests to the different endpoints that are a part of the config here. It'll make a request to the config endpoint with no cookies, no information identifying what website the user is on. It'll then make requests to endpoints defined in that config file. It'll fetch the accounts endpoint with IDP cookies to know which accounts the user is logged in as. It'll also fetch the client metadata, which, yes, it seems backwards, but it's because the client presumably has pre-registered at the IDP. There's a link to an issue for when that is not the case. Then the user will see a prompt and it says the browser is finally able to collect all that information and say, hey, this user is trying to sign into this application. Do you want to continue doing this? And only after the user clicks yes, finally, the browser goes to the identity assertion endpoint with IDP cookies, and it tells it which RP origin is making this request finally, and which account the user chose. And it's assumed that the IDP will return back some string. In the current API, this is called token, mainly because the Google's implementation of this returns an ID token, which was kind of the assumed way this would work. But we're going to come back to that as well. Okay, putting FedCM on hold for a minute, I want to also talk about the other proposal, which is cross-site cookie access credential. This is meant to be a lighter weight version of the previous API, and you'll notice it has far fewer steps. This is essentially a browser API that enables a website like an IDP to put something in the browser that a different origin can then fetch after prompting the user. So think of it as the IDP can drop something into the browser, a string, and it can say it's only allowed to be fetched by certain origins, certain clients or RPs. And then when the RP makes a request to fetch that, again, the user will see a prompt saying, do you want to let this one website get data from this other website? And then it'll eventually get that string. So that's the extent of this one. You'll notice it's much smaller surface area of an API. So, okay, how can we use these for OAuth? I do have a link to a GitHub repo, which I've linked to on the slide here. It's not really written up as a spec right now. It's more of an implementation guide for how you could build an OAuth flow using FedCM, and it kind of walks through everything that I explained and all the requests that get made. I don't think it's really ready for a draft yet until the FedCM spec itself stabilizes a bit, because there's still a lot of open issues and details here and there that need to get resolved and stabilized and put into the spec before we can really formally profile it. The alternate profile, the cross-site cookie access credential spec, unfortunately did not have time to prototype this before the session today, mainly because the UI for it is actually not shipped in Firefox Nightly yet. This one's being mainly driven by Mozilla, but I am interested in trying this. So, okay, let's go through how we do this in FedCM first.
Do you want to take questions now?
It depends on the question. Let's see what Dick has to say.
Go ahead, Dick.
Aaron, Descartes, how relevant do you think this is going to be given that Chrome is not going to deprecate third-party cookies? And is there any activity on any browser besides, the people that are building have their own thing of supporting this, like a Safari or mobile going to support FedCM or anybody else? Because
Sure.
my impression of FedCM was it was a way for Google to continue to have the user experience they had with third-party cookies in Chrome when third-party cookies went away, because their little widget used third-party cookies.
Yes, fair. Good question. So I assume Tim is also up there to answer this, but my take on this is that yes, third-party cookies not going away anymore, apparently as of Monday or whatever.
Not going away with Chrome.
Not going with Chrome anymore means that does change the priority of this possibly. However, it's possible. I think it's very possible and very likely that this will provide a better user experience for users, even if third-party cookies weren't going away and redirect and link declaration weren't going away. And there's a couple features in here, in particular the experimental IDP registration feature, which brings a whole brand new user experience to the browser that previously wasn't possible at all. So I still think there's reasons to look at this for those reasons.
Okay. As a provider, I find it super unlikely that I would ever support FedCM because it breaks a number of things.
Okay, thanks, Dick. Tim.
Hey, Tim Cavalli. First, I'd ask you to create an issue with the things that broke, because that'll be helpful. FedCM isn't actively, you have to actively invoke FedCM, so it doesn't break anything.
Yeah, I was going to say.
I filed issues that are still sitting there 18 months later, so.
Come back and have the discussions.
That's not what I wanted to say. I would argue FedCM is more critical now than before, because we should be careful saying third-party cookies are staying. Third-party cookies will now be a choice for the user. And as we've seen on the app platform, when users are given a scary prompt that says, do you want to be tracked? They click no, of course. So FedCM provides a consistent layer above all of that to provide these experiences, because arguably it's going to get even more fragmented, right? Today, you can at least detect based on user agent and client hints the behavior of a browser. Now you're going to have the same browser version down to the exact version number that behaves differently for different users because the user changed their consent. So I would argue FedCM is more important than it was before.
Okay, thanks, Tim. Heather.
Heather Flanagan, Federated Identity Working Group Chair. So we're definitely continuing to work on this. It's interesting to me that, of course, the W3C tag took Google's high-level statement that they were no longer going to deprecate third-party cookies, and basically, to sum up, where it said, "What are you thinking?" And Google made their choice, perhaps, but the regulators aren't happy with it. The W3C tag isn't happy with it. I think we're still going to see this development in that space is just going to be odd. If you talk to the Chrome team directly and say, so what does this mean? They say, this was news to us too. So we'll see how it all goes.
Thanks, Heather.
Okay, I want to keep this moving. So I want to get to the OAuth parts. So slotting OAuth into this, it's not entirely obvious at first because of all the documentation and existing examples that you'll find will return an ID token in this as a response to FedCM. So instead, what I've done is instead of treating this as a ID assertion, you treat it as an authorization endpoint in OAuth, meaning that you'll actually get back an authorization code. So you start the flow with sending OAuth request parameters. You get back an authorization code from the browser, and then you can go and exchange that for a token like you normally would if you hadn't used FedCM. Importantly, this means we can do things like enable confidential clients by actually doing all the OAuth parts on the back end. We can do things like PAR. And this doesn't involve redirects, which means it's roughly equivalent to prompt none. So here's what this looks like in using the API. And this is using the new params feature, which is still relatively new, not actually in the spec yet, but this is what's in Chrome. So you put all your OAuth parameters in this params object, and then at this point, the user will see a prompt, and then once they click continue, I skipped over all the other stuff, but eventually the request goes to the assertion endpoint, which contains the custom params that the client had put in that first call to the browser. This looks very, very similar to what would be sent in the query string of an OAuth authorization request, or in the post body of a PAR request, which means the response of this is actually an OAuth authorization code rather than a token directly. This means that once this returns, we're back in JavaScript land. So the JavaScript can just make a request to the token endpoint at this point. Plain OAuth request. Now we're totally done with the FedCM flow. We're out of that context, and we're just in plain OAuth. So this works. I've prototyped this. Philip has prototyped this, and I'm pretty happy with that architecture just because of the way we can pretty seamlessly slot everything else into it. And this is what's documented on that thread. Philip, I wanted to get to the question.
I just want to interject very quickly.
Okay.
It's not just the authorization code. You can actually use any of our response types and response modes. You can use any response mode. So you can do your code ID token to do FAPI. You can likewise do response modes such as JARM, because the token can be assigned JOT, which contains then the authorization response. And you can combine that with the number and plethora of response types.
Yep.
That's all I wanted to say.
Thanks. Yeah. And there is an open issue to track this response changing to actually allow the IDP to return JSON data instead of just a string. So if you're interested in that, there's an issue for that. Okay, so the big question here, you may have noticed this params underscore situation. I guess I don't have time to go over this. This is how you could use a backend to do this. But the main question here is, how do we want this params thing to work, and how would it best work for OAuth? Because there's a few different options. Whether to prefix the custom parameters with param underscore, whether to prefix the FedCM parameters with FedCM underscore, and leave the rest of the custom parameters as is, or do everything as JSON and namespace them both effectively, realizing that this is no longer a simple request, so it does require cores. This is something that if you do have an opinion on, I guess we don't have a lot of time to discuss it here, but it's okay. It's pretty much just bike shedding, but this is feedback that the working group is interested in getting from the OAuth group. So I'm going to leave a link to this issue on the screen here, and you can go comment on GitHub here if you would like to chime in.
Yeah, Christina has a comment here, so go ahead.
If I understood correctly, this feels very similar to what we have already done for OpenID for VP for the browser, for the digital credentials browser API. And it depends on your goal. For us, the goal was to enable existing OpenID for VP implementation to use this new digital credentials browser API with minimal changes. So what we've done is, I think, very close to your last proposal, where it's a JSON object where you can just put in existing OAuth parameters without changing parameter names or prefixing or anything. Just put in there, and you just add code to take it out from this namespace part. So that would be part of our experience.
Great.
Okay, thanks, Christina. Anything else? Aaron, do you want to wrap up quickly here?
Yeah, I guess I'll just wrap up with, I collected a couple of, button moved out from under my finger. I collected a couple of issues that are on the FedCM GitHub here that are relevant to OAuth related things of deploying this in an OAuth ecosystem. So if you are curious, please do check these out. These are issues that are going to come up if you start building an OAuth, mainly IDP, to try to actually integrate that into the FedCM API.
Okay.
And
awesome.
hopefully I'll be able to come back later and give a demo of how this, an alternate version of how this looks with the cross-site cookie access credential API. The big thing to remember there is that it's essentially just you're able to drop, the IDP drops one thing that gets pulled up by the RP. So kind of have to think about the flow a lot differently rather than being more dynamic like FedCM.
Okay. Thanks, Aaron. Thanks, Philip.
Great.
Richard. Do you want control? You want to drive?
Oh, however you like. You've already got them up, so we can go. So, hi, I'm Richard Barnes. I'm here on behalf of myself and my co-author Sharon Goldberg to talk about this PICA draft, which we had some discussion on the mailing list, and this is going to kind of recap and see if we can find a path forward. Next slide, please. There we go. So what's the problem we're trying to solve here? As you may have heard me mention a moment ago at the microphone, sometimes you don't have internet connectivity. So if you look at how a lot of JOTs get validated right now with things like OpenID Connect, you look at the issuer of the JOT. The issuer is in the form of a URL. You do some HTTP-based discovery to look up the keys that are associated with that issuer with which you will validate the JOT. Which means that if those keys are unavailable for some reason, you fail to validate the JOT. Now that can happen because that HTTP endpoint happens to be down at the moment you're validating. It might be because the OpenID provider or the issuer has rotated their keys and the keys you're looking for are no longer there. So the idea is to make an object that can provide a little bit of persistency to patch over these cases where there's spurious failures in validation. Validation should have succeeded, but it failed because there was this kind of mechanical failure in the middle. Next slide, please. There's a lot of echo up here. So just to give folks an idea of why this is salient, folks are looking to take a bunch of the verifiable credentials that are coming out in various domains now and start to patch them into applications. So for example, you might use these in an end-to-end encrypted WebEx call to authenticate the other participants in the call. Or you might use it to prove that your authority to go into a concert where there's an overwhelmed cell phone network. The idea of PICA here is that it should be possible to cache these proofs of issuer key authority. The fact that these validation keys, these verification keys belong to a given issuer, either in the application or in a client. A wallet that holds a credential could cache it as well, it'd be kind of like caching intermediate certificates. But the idea is that even if the issuer of the credential is unreachable at the moment of validation, it should be possible to verify that a credential came from a given source, including verifying that looking up the keys that go with a given issuer. Next slide, please. So that was kind of addressing the availability case, case where you might have a connectivity, a reachability problem with the server. Some folks in the container side community have a different kind of time-based challenge with these kind of live key lookups, which is that they have these use cases where they want to be able to reason about the past, to be able to reason about something that was signed in the past. So they have some of these timing authorities that will prove that something existed at a prior time. And so they're looking for some artifact that they could make that says at time T, issuer example.com was using this set of signing keys. So they're missing a thing that has that sort of statement about which keys an issuer is using at a given time that is traceable back to the issuer. Yeah.
So, Roy Williams. So I would like to understand why skip and counter signatures wouldn't work here.
I don't know the technology you're talking about. I'm happy to talk offline. I think this may be a slightly, so what I'm building up to is a very minor variation on what OAuth and OpenID are doing today. So maybe there's a little bit simpler there, but happy, like I said, happy to chat offline. I'm sorry? Okay. Hannes, please join the conversation. All right, next slide, please. So this gives you an idea of some of the use cases. So like in transient non-reachability and also this kind of rotation problem. So really the idea of Pika is to make this thing in the middle. So right now, these things on the right hand exist, the things on the left hand side exist. So verifiable credentials get issued in the form of JOTs or CWTs underneath an issuer. And when you go to do the HTTP requests to get the keys for that issuer, you end up relying on the X509 certificates when you do the HTTP request. So what the Pika does is sit in the middle and bridge those two together. So instead of that glue being the bytes of the HTTP transaction between the two, the glue is just another JOT that is signed underneath the certificate you would have trusted anyway and contains the keys that you would have fetched over the HTTPS connection. So this is basically like the minimal possible deviation from whatever you're doing for discovery today. It's just taking an HTTPS connection, which is transient and happens in time, and transforming it into an object which is signed and can be cached and stored and reused. Make sense? Cool. Next slide, I think, just puts that in, yeah. So this is just, an illustration of the structure. It's just a JOT. Payload of the JOT has keys. Thanks to Mike Jones at the last IETF meeting, pointed us to a bunch of really good prior art from OpenID Federation, which is making similar statements of issuer key authority. But basically the idea is you have some keys with lifetimes and key IDs in the payload. You sign in the signature block, in the header, you have an X5C header, which has the certificate chain that would have, the moral equivalent of what you would have had in the HTTP, had the HTTP server present in that live HTTP request. So again, the idea is to keep the trust structure exactly the same as we have today, not make any changes to that, just translate it into something that is an object instead of an HTTP transaction. Next slide, please. So we had some discussion of this at the last IETF. We had some discussion at an interim, and the chairs issued an adoption call after that interim. I think the conclusion, if I were to summarize out of that, correct me if I'm taking liberties here, but my interpretation of the feedback in the adoption call was that we got a lot of good interest, a lot of folks interested in solving the use cases we've talked about here, but a couple of challenges to address. One Mike and Giuseppe raised, Mike observed that there's been kind of a long-term trend away from using X509 at the application layer, which is totally sensible because X509 is like old ASN1 technology. It doesn't align well with a lot of current ways delegations happen. And it's just a lot easier to program with things like JOT. So the observation is that this, the reuse of X509 in the way we've proposed here kind of cuts against that trend a little bit. And it may be that in the future, like we would want to take that use of X509 and generalize it away in the same way we've done it in the past. So the issue to clear up here and to make sure, and I appreciate Mike, thanks for the discussion this week and clarifying that. I hadn't quite gotten it from the mailing list discussion. So I think the to-do here, which I'd be glad to, I haven't filed an issue yet, but like it definitely would be like issue number one on a working group repo if we adopt this, is to make sure that we make clear that that other ways of authenticating this are possible in the future. We're being concrete in the moment so that we have a definite algorithm that you can write code to, but we want to have upgrade paths available, and I think we can kind of sketch out what would be necessary to establish that upgrade path. So I think that was kind of the feedback in the adoption call. I think that's how I would translate it into an issue if we were to adopt something. The other thing is the other kind of issue that came up is that there are some security considerations we need to keep track of when we take certificates that are of a form that is acceptable in the Web PKI and use them for non-TLS applications. So As the draft is written right now, it has not great security properties. I will freely admit that right now. In particular, the draft right now says that if the issuer URL is https://example.com, then the end entity certificate and the certificate chain has to authenticate example.com, right? Not great security properties out there because, I've got two boxes I might like to consider here. I've got my Pika signing box sitting in the back of the infrastructure under lock and key. And I've got my web servers out facing the public internet. So like very different compromise risk, but this says I now have certificates on both of these attesting to the same domains. So that if that web server gets knocked over, it can get used to issue Pikas that this high security box would be expected to issue. Not great. So we need to kind of obviously write up this sort of stuff. And there's a variety of mitigations we can apply to make this better. For example, one of the easiest and very effective things is to add a prefix. So like instead of saying the Pika signing certificate has to have example.com, you could attach a prefix that says the Pika signing certificate for example.com has to authenticate the name, say _Pika.example.com. Right, so you'd have a certificate that would only be expected to exist on your Pika signing box. There would be no reason to have that certificate on a web server. There are also some mitigations you can have around lifetimes, limiting the lifetime of these things so that if a temporary compromise wouldn't lead to like a 3-year-long Pika or something like that. So definitely some things to keep track of here, but I think they're tractable. And the next slide is my last slide, which is just to raise the question of whether we think, obviously, hopefully we've established that there's interest in solving this problem. And I'd love to get to the question of whether we think there's enough clarity around the issues. We think that this is a solvable problem, that there's a tractable solution here. We should go forward as a working group. Yeah, Leif.
Yes, I actually like this. And it was, as you point out, it gets us a way to get away from the web PKI as a kind of way to solve all security problems on the web, which is a good thing in my opinion. As you kind of alluded to, one of the good side effects here is I can have operationally sound web PKI certificates on my web server while having things that sign the sensitive stuff, the security sensitive stuff on my artifact, my well-known artifacts, with things like an EIDAS sort of compliance certificate, right? While not having to kind of mix those two together. It's an excellent thing, right? Yep. And I'm sure that whatever Giuseppe and Mike has told you about OpenID Federation, we can figure out a way to kind of fold these things into. This will be a very, very useful thing. I will note, though, that so I'm up here supporting adoption and working on this. I will note that there might even be prior art in some work that Stefan Santason did early in a few years ago, basically to record identity data in notary evidence associated with digital signatures of PDF and XML, where you're basically building a notary system, right? Anyway, so the people have kind of been circling the same kind of problem for that. So I think it's great. Yeah.
Yep. Thank you. And if you have links to that prior, I'd love to see them.
Okay. Thanks, Leif. Philip.
Thank you. Hi, everyone, again. Can we go back to the example with the X5C header? I guess while I'll talk. Thank you, this one. So this hinges on, I see two things. First of all, having the possibility to properly process the X5C JWS header parameter, which generally isn't widely supported in your HOSE implementations. And on top of that, even if you were to actually have the possibility to parse an X5C and traverse the chain, for which the support is even less, the support of the programming languages, at least the ones that I have encountered, that would allow you to take a certificate and throw it against the root CAs that you have on your system, you're going down the funnel, right? You have your JWT libraries that don't support this. You have your programming languages that don't give you structs or constructs in order to work with certificates. and then they don't even have the possibility to throw the validation against the root CAs that you have on your system. So this is, I wouldn't expect wide adoption from implementers, is what I'm trying to say.
Yeah, I totally understand that this introduces some implementation challenges. I think light bulb went off for me when I was talking to Mike when he distinguished between kind of transport level usage of X509 and application level usage. So yeah, there would definitely be additional work to be done in verifier libraries. We had some feedback on the list from a couple of potential verifier implementers who said that they thought this would be tractable. I am also a potential verifier implementer, and we have implemented some comparable certificate chain validation logic in this kind of parallel code path. So I think it would be doable. But you're right, you're totally right. It would be work.
I think the moment you start thinking about subject DNs and you start thinking about alternative domain names, at that point it just you're at the mercy of the implementer to get everything right, and this is traditionally an area which HOSA library implementers just want to avoid completely, myself included on at least 2 libraries.
Okay, thanks, Philip. Atul.
Yeah, hi. I mean, this looks like a certificate for the OP key, right? Is that sort of a good assumption? And then, how long is it going to be valid for? How do you revoke it? All the concerns that you would get with certificates, right?
Yeah, definitely. This is sort of extending the PKI to talk about the OpenID or the OAuth issuer, JOT issuer keys. And so, yeah, you would have similar concerns about lifetime and revocation, things like that.
Okay, does that answer your question at all? It's good. Okay.
I think, I guess what I heard is that the question is valid. I didn't hear an answer as such.
So maybe could you restate the question?
That, how do you revoke this certificate, for example?
Excellent question. I don't think that there's anything in the draft right now, but you could certainly see adopting things like status lists for this in parallel with other types of JOTs that were being discussed earlier. That's a good question. We should definitely address that in the draft.
Yeah, thanks.
Okay, thanks Atul. Peter.
Peter Castleman, single key use enthusiast and fearmongerer. First of all, I want to thank the authors for this work. I think it's a great problem, or it's a problem that's really it's a great solution to be working on, or problem to be working on. Also, thank you for taking into account the feedback on the security pieces. I read the latest draft. I'd be very supportive of this and would love to work with you to figure out if there's a way to make sure that we can separate these concerns in a safe way. So, thank you.
Okay, thanks, Peter. Yeah, like Hannes and I think we want to kind of get a feeling of the room here and make a call for adoption again. Obviously, the official one will be on the mailing list, but let's try to do it here and see what we get here.
Obviously, if anyone has any last concerns, feel free to jump to the mic. Okay. 2.5 minutes.
Go ahead, please.
Yeah, I mean, I'm just not sure if I want a new certificate format, right? Why not just use X509 certificates in that case?
I think that the idea is to reuse the web PKI, in which case the end entity certificates talk about domain names, not about open or OAuth issuer key, JOT issuer keys. So I think, much like kind of TLS delegated credentials, the idea this is extending the PKI into an application-specific domain, and so it makes sense to have something that's not an X509 certificate.
Okay. All right.
Okay, I don't see any changes there. So we have some rough consensus here. People mostly in support. There are some people that have some concerns with this. Let's try to continue resolving those issues and see what these people that are against adoption. You want to say something?
And so I just want to repeat the value. So we have in the room and of course from remote as well. Today we have 11 yes, 3 no, and 9 who have no opinion. And so I think I will, as always, repeat that on the mailing list, and then yeah. But looks so far pretty promising.
It is promising, but we would like to hear from those people that voted no and what's their concerns, so we could hopefully Richard and team can address those concerns, right?
Yeah, absolutely. Happy to
Okay.
have more feedback.
Awesome.
All right, thank you.
Thank you.
And thanks to folks for the feedback.
Yeah.
Yeah, I don't know where this clapping comes from these days. I heard that a couple of times.
Like I don't know where this coming from. Like we didn't used to do that. Some new people came here and okay, David, it's your show now. Oh,
This clapping wakes up half of the room. You know?
okay.
Right,
Which one do you wanna? Yeah. Oh, okay,
I'll let you
actually,
pick.
yeah. Well, you pick if you want control.
Do RAR first, I guess.
Okay. So, did you ask for? Like, can you ask for it? Because
I did.
Otherwise, I don't see it here. Okay. David.
Meanwhile,
David should be here. David, here we go.
did that
Okay.
work?
Yeah. Now you can share whatever you want.
You want to choose the one to share? Oh, you need to pick. Yeah. Cool. I'll try not to trip. There's a thingy behind me. All right. My name is David. Some of you know me. I'm the Zachmol guy. No judgment, please. And I do tend to insert the word authorization everywhere I go. So I think OAuth stands for open authorization. Oh, wait, no, that is actually true. It is open authorization. Anyway, it is not open authorization?
No.
Not anymore?
No,
All right.
Want to start a war here?
And yeah, I'm going to talk about a profile that my colleagues in the OauthZen, OpenID OauthZen working group and I put together. I think there's a few members of OauthZen in the room. Yep, Steve, Phil. Anyway, as I was writing these slides, of course, the whole CrowdStrike debacle happened, so I thought I would have a bit of fun with that. Normally, this is animated, but I guess animation doesn't work. Also, as I was posting the profile in the past week or a couple weeks, I got a lot of feedback. Thank you very much, both from this community, but also the ID Pro community and the OpenID community on the fact that someone already attempted to do a RAR profile at IETF 119. I saw the video. And I just want to say that it's really legitimate feedback, but this is not about CEDAR or policy language, just to put that, to clarify that. One more thing, we were working on this profile at Identiverse with my co-chairs, with Yves Mailer, with Jerry Gable. And at some point we had to plug our computers in, and all we found, this is in the US, this was the plug we had to deal with. And I've never seen such a plug before. I think it's Swiss, but not too sure. Italian? Okay. European plugs are weird because they're all the same, except they're not the same. It's kind of strange. And that's actually the matter here with OauthZen. The reason why we came up with OauthZen in the first place is that if you look at authorization systems, I'm going to call it like true authorization systems, as in you send a question, you get an answer back. So can I do this, yes or no? If you look at, say, OPA or Zachmol or Alpha or CEDAR or other systems, Cerbos, OSO, there's many different systems you can choose. They're all 95% the same, but they're 5% different. And so that's why we created OauthZen. We really wanted to make sure that we all spoke the same language, given that the question we're asking is a very simple, sensible question, and that the answer that we're returning is essentially a yes or a no, a Boolean, right? It's incredible that we can't even standardize that. The other reason for doing Auth-Zen, of course, is that if you look at OWASP, if you look both at the top 10, but also the API top 10, the #1 issue on both lists is broken access control. I don't know if any one of you saw the article on GitHub and GitHub Access Control that came out a couple days ago. They don't talk about broken access. Well, IDOR is the term in OWASP. They call it something else for GitHub, but essentially, if you delete something in GitHub, it's still accessible. So there's an access control issue. Anyway, Auth-Zen is under the OpenID Foundation. It's been around officially for the past 2 years. In practice, for the past year, it was sort of revived at Identiverse 2023. Within 6 months, we had a draft of what a request would look like, a draft of what the response would look like, and then we got 12 implementations to adhere to that request response format. And of those 12 implementations, we have a mix of policy-based approaches, we have a mix of graph-based approaches, and then a mix of other approaches, proprietary approaches. Auth-Zen has really three goals. #1 is to standardize the PEP PDP, so PEP policy enforcement point, PDP policy decision point approach, and also education, teaching people about externalizing authorization. This is also where there's a bit of work that we need to do between OAuth, I think, and let's call it the ABAC community, for lack of a better word. And it also has a mission of creating design patterns. For those of you who were at IIW in October, so not the last one, but the one before that, Eve and Justin and Alan and I ran a session called P*P versus ASRS Smackdown. It was all about finding common patterns that we can use for authorization, avoiding the abuse of OAuth, where this is a personal opinion, by the way. Sometimes I feel that OAuth is being abused to do things it shouldn't be doing, and using ABAC where it should be used. All right, Okay, this is what a request looks like. It's very simple. It's essentially just JSON. You specify a subject, you specify a resource, an action, and then context data. In plain old English, this would be, hey, can user Alice read account 123? By the way, it is 10 p.m. It's way past, 1:22. I don't know how to read time. AM, I guess, in this case. It's way past my bedtime. And the response that you get back, the simplest form that you could get back is a decision shrew. This is the interop that everyone went, so the 12 vendors and frameworks went against. This is what the pattern in ABAC looks like. Okay, everyone knows this picture, I guess, very familiar to everyone. The key components to remember is the PEP, policy enforcement point, and that's the thing that protects your infrastructure. And the PDP is the brains. It's what I guess you could call the authorization server or service. It's a good thing that ABAC never called it that. We avoid term collision with OAuth. And then, of course, this is the RSAS pattern that, although I have a slide there, I still don't fully understand. I have to, confess to that. Although I've been doing OAuth for the past 3 years, I still don't fully understand OAuth. Please don't shame me. This is not recorded, is it?
No.
And it.
Yeah, you can put it into your CV.
And it's going on YouTube too.
The what? What is real? That it's recorded. Oh yeah, I know it's recorded.
No, and it's going on YouTube. That's.
Oh yeah, I know that too. You sent me the 119 video. Okay. There's way worse on YouTube. Anyway, so before we get into the RAR profile itself, just a note on the combined architecture. Some places where we could actually extend OAuth with ABAC is have an authorization server call out to PDP. Does there need to be an RFC for that? Maybe we could talk about it, but it's not really the point of RAR, or I don't want to abuse RAR for that. And then, of course, you could call from a resource server to PDP. That's outside the scope of OAuth altogether. So in RAR, when I read the RFC, what I heard is that RAR lets you create a way to send a more fine-grained authorization request or authorization details from the client to the authorization server. I think I misunderstood the intent, though. Because when I read that initially, I thought, ooh, it's a PEP talking to PDP, which it's not. I understand that. And I want to get all your feedback. And Justin, you already gave me a lot of feedback, so thanks for that. Which, by the way, in your blog post, you say one of the key motivations behind RAR was admitting as a community that a lot of times you need more than a set of scope values to properly describe access to an API. I misinterpreted that. I think it's because I'm biased. I think that deep down I knew that you meant something else, but I read it to mean I need a PEP and a PDP. Joke aside, this is also, I think, a picture from your blog post or from one of the RAR resources, maybe Aaron, I don't remember. But I get it that now essentially what the client is saying, okay, the user needs to transfer so much money, and I'm sending that to the authorization server, so the authorization server can actually give me an access token back. But even then, is there room for an auth-zen formatted request in RAR? What I'm really trying to do is to bridge between OAuth and, let's call it fine-grained authorization or ABAC. This is not a picture I took. I took it from Unsplash, so I guess I took it. This is in Vancouver, though, in North Vancouver.
Capilano?
Yep, Capilano. The auth-zen request response profile for OAuth, you can go look at the profile already. It's essentially to define the structure of the RAR request. Instead of having it roughly freeform JSON, today it's actually an array of JSON objects. What I'm suggesting is that it still is an array, of course, but it's an array of auth-zen requests instead of just plain JSON. And because we do that, initially and in the current draft, I mentioned that the type of the request should be auth-zen. Now, Dave Hyland in APAC or in Australia pointed out that the type actually means something else for, at least in FAPI and in open banking, they use that to distinguish between different types of banking. So maybe using auth-zen as a value is not a good thing. He's wrong? All right. So yeah, I think I don't remember how many slides I had, but I've already got some feedback to the use of the type field, and I want to hear what you guys in the room and online have to say. Also, the fact that RAR is really about scoping access delegation. I understand that, and auth-zen is more about direct access control. I still think the format is legitimate in RAR. Ralph, I'm sorry, I think Ralph Bragg. Am I getting the last name right? Gave you some feedback as well. In terms of where it would fit or not fit. And then one more thing, though, that's interesting. One of the things in the RAR profile, in the standard RAR profile, not the auth-zen one, is that you have this ability for the client to say, okay, the user wants to move money from A, to B. You don't necessarily know where from. And then in the authorization server has the ability to complete the authorization details and send that back to the client. That's something that auth-zen will be able to do in the future. We have this idea of course, the yes/no authorization API, as I showed you a minute ago, but also something that a tool calls search, which is this idea that sometimes you don't want to get a yes/no authorization request, but rather you want to know, hey, tell me which accounts I can list or which accounts I can take money from. And that fits really nicely with the second intent in auth-zen RAR. And sorry, not OAuth RAR, not auth-zen RAR. And yeah, just other things, because I'm new to IETF, I'm fakely newish to OAuth, kind of, sort of. I'm interested in seeing how auth-zen potentially can benefit from transaction tokens, or the other way around, transaction tokens can benefit from auth-zen. And other areas of OAuth, you know, selective disclosure is something I haven't looked at, but SDJOT, I was wondering, oh, well, if you do selective disclosure, who decides on the disclosure, and could there be a policy there? You know, I'm trying to fit a policy everywhere in my mind. And that's it for the first presentation. A couple links here if you want to read up on what I used, and that's it. Yeah.
Okay, we have two people in the line here. Darren?
Hey, David, thanks for writing this, and sorry I couldn't be there in person. My comment isn't about Cedar, although I can answer that if anyone has Cedar questions. I was more just reading the spec and just trying to make sure I got the right mental model. And I saw that you can pass in sort of auth-zen contents when requesting a token. Most of the RAR profiles then, or I think all of them, then include some artifact in the token that comes back that represents the scoped down permissions for the continual use of that token. And I didn't see that in the spec. And then as a result, I was just sort of having trouble piecing together how someone would actually use this to solve certain problems, like what comes back in the token, how is that evaluated with auth-zen, and so on.
Yeah, that's a good point. I kind of hit that thing as well. Like initially when I wrote it, I had not fully understood RAR. I guess I made a mistake. And so when I realized that the RAR response is actually essentially a list of things you have access to, not just a Boolean, that got me thinking that, well, instead of returning an auth-then response, you actually want to return the original auth-then request, potentially enriched with the things you know that you're allowed to do. So very much in line with what an authorization details looks like today.
Got it. Maybe just one last thing there, and I'll yield the floor. If that's true, then I think there is a bit of slippery slope in that what would be in that response in auth-then format, in effect, is a policy if it defines what's allowed. And so I think there's still some questions about how to connect the dots then to the rest of auth-then.
I don't see that as a policy. It is in a way a policy. You're right, but I don't see that as such. I see more that as a fully filled out question. You know, the question is, can Alice view document 1? And you reply, Alice can view document 1. As it turns out, the way to write this is the exact same way.
We can take that in the list. I think I think there are some questions there, but we can dig into that then.
Yeah, but good points, Darren. Thanks.
Justin
Richer, and I was not prepared for that slide. But I do think that this is interesting work. As I say in the blog post that you referenced there, you know, the primary use case of RAR for a lot of people is the client expressing to the AS in a more rich way the kinds of things that I want.
Yeah.
But really under the hood, it is just a fancy set of scopes. So all of the other places that scopes show up in OAuth, RAR stuff absolutely makes sense to show up, including this notion about what the token is good for, which might be a different view to the client and the RS. So the stuff that's either in the token or in an introspection response or something like that might actually be different from what you're telling the client that the token is good for.
Yep.
Additionally, when we wrote introspection, we intended for it to be allowed to be extended with additional context and stuff like that to say, this is the token that I got, what do I do with it? The whole, one of the major intents there was to also say, and here's all of the other information that I have about this. So is that token good? Is it not? What is it? You tell me what to do. Yep. And so it very much fits this type of, you know, Xacaml protocol-ish kind of concept pretty well. Same feedback that I gave to the Cedar profile. I think that this is good work. I think that there's a lot of syntax that needs to shake out. What I think is interesting about this is that it took the opposite approach of the Cedar profile. Instead of using it to pass policy language, it passes a data structure, whereas the Cedar profile is, you know, here's the compilable language that you can run. I think that there's probably going to be space for both. And so I think it's a question of if we do decide to go down this path, do we want to handle both cases? What's the trade-offs there? I don't have the answers for that. I am not an expert in the policy language type of space. All that said, I do think that RAR not only gives you a place to put that stuff, also gives you a bunch of sort of additional common properties that make sense. So like actions, locations, all of that other stuff would need to be interpreted in terms of that, would need to be defined in terms of that if you wanted to reuse them. But I think that there's potentially some value there.
Yeah, and
Brian's shaking his head in all directions over here, and I'm not. No, it's good because I honestly, I probably agree with all of Brian's head shaking there, that because I think that there are a lot of dragons down this path, but I do think that there is also some value here.
So I agree with what you said, and thank you for the feedback both today and prior days. And also, I like what you said is interesting because maybe if there was to be an auth-then profile of OAuth, it would be more about mapping what a raw request looks like into an auth-then request that might be then sent off to a PDP, in which case that profile would sit somewhere else in the pipeline. It wouldn't be sitting in the client to AS or RS to AS. It would be like AS to something else, kind of what I had in my diagram. So that's worth exploring as well, because then we can leverage those additional properties.
Okay, Jeff.
Yeah, Jeff, just for the record, for the minutes, RAR is full of open banking and financial example and all of that, but now Smart on Fire has declared RAR as an experimental function, so I'm super eager to see more profile for RAR due to that. It was just a comment.
Cool,
Okay.
thanks.
Thanks, Jeff. Atul.
Yeah, hi. If you go to slide 9, it sounds like
9?
what you're proposing is between Yeah, that one. So it sounds like what you're proposing is like the authorization server or the resource server being the requester in this case, and the PDP actually being the responder in your raw request and response. Is that
No, no,
right?
no. This is a diagram that is outside of RAR. This is just showing where OAuth and Authzen could work together. This is not tied to RAR.
Okay.
I guess my slide is misleading.
Okay. Yeah, I mean, then I'm sort of just a +1 to Darren is, I guess I just need to understand this a little more about how this is, what the response is going to be like, and how is it going to be used.
So we can take that in the Authzen weekly calls, Atul. But
yeah,
the use of the Authzen requests in the RAR profile would be between the client and the authorization server, or the resource server to the authorization server, where RAR exists today.
Okay.
This diagram was really, I'm sorry for the confusion. I should have split the presentation into two, one just for RAR and then one for where does OAuth and authorization, where do they work together? What can they work together?
Okay. Okay.
Thanks, Atul. Gonna switch gears to the next one.
All right. How do I change slides?
Did you do something?
No, he's asking.
I need authorization.
I gave him. Yeah, so the last one, no?
All right, this will be quick. All right, so like I mentioned in the previous talk, all I talk about is access control policies, policy, and nothing else. So bear with me. Well, okay, so I presented this last Sunday, and given that I didn't know the IETF crowd and I didn't know how identity focused or identity unfocused they would be, I did an introduction to what authentication is. And the bottom line here is there's lots and lots of standards for authentication. And when I say authentication, I mean it in the broad sense. It's not just about who you are, but it's also what you can be. So proving that you're 25 is a form of authentication. It doesn't really matter that you're Joe or Mario in my example. So lots of standards in that space. OAuth is one of them. There's, of course, SAML, SCIM, many standards. You guys know this better than I do. But beyond authentication, we also want to do authorization. And when I say authorization, I don't mean access delegation. I mean actual proper authorization. So like when you enter a country, for instance, the border control folks will check that you're allowed to enter the country. So this is the case here. And what it means is that somewhere there's a policy, and I mean policy in the broad, neutral, non-technical sense. There's a policy that dictates what can or cannot happen. So there's a policy in Canada that says if you come from the US, you just show your passport and you're in. If you're under 16, you can actually show your birth certificate and you're in. So there's rules like that that are defined in the policy. Okay. Generally speaking, when I talk about authorization, I think of MAC, but we also have to think of other models. There's two major models, right? MAC, mandatory access control. If you all know this, just nod and we can move on. And then DAC, discretionary access control. The work I've focused on for the past 15 years is very much MAC, but in the past, say, 5 years, with the advent of Zanzibar and the advent of frameworks and companies on top of Zanzibar, we're also talking more and more about DAC. And then below MAC and DAC, there's different ways of implementing those. There's, grossly speaking, policy-based systems. There's a graph-based system. So the author of the diagram, Alex Babineau, is a graph nerd, I guess I would say. If you think I talk too much about policy, you should listen to him talk about graphs. There's also ACL-based approaches to authorization, and they all have their pros and their cons, right? But then if you focus on authorization languages more specifically, you'll see there's a flurry of languages. There's Alpha, there's Rego, there's Cedar, there's Polar, there's IDQL that Phil, you've been involved with. There's ZACML, and there's possibly many more languages I'm not even thinking of. There's vendor-specific languages too. So if I change views, if I look at the lay of the land from a different angle, Alex's view is very much from like the types of authorization, and you walk your way down. My view was just writing down all the things that relate to authorization and trying to group them. There's vendor-specific stuff that exists as well. Microsoft has a language called SDDL, or used to have a language called SDDL for file-based access control. Programming languages like Ruby and Java and other programming languages have their own specific ways of doing authorization. So it's a mess.
And if you look at the timeline, of course, it goes back to the 70s with ACLs, and then it moves all the way to 2023 with the introduction of CEDAR, and also some of the work that's happening within OAuth, actually, like some of the new profiles they try, or I feel that they try to get closer to fine-grained authorization, which is great. And of course, when you feel like there's too many standards, what do? You create another standard. Is that not what you do? So alpha, for those of you not familiar with alpha, it's the abbreviated language for authorization. You can do any kind of authorization model, RBAC, ABAC, REBAC in a single language. It doesn't really matter as long as you have an attribute to model, you could express that model. It was initially drafted under OASIS ZACWL, and then nothing happened. It stayed a draft for a lack of engagement, I want to say, and maybe standard fatigue or whatever you want to call it. Today, OASIS ZACWL only meets like about every month. There's only 4 or 5 different members, so it's not as active as what it used to be. I'm not myself a member. Maybe I should rejoin, but that's a different conversation. Alpha has all of the goodness of ZACWL, allegedly none of the bad. Namely, the XML notation is out the door. I'm sorry, Eve. A bunch of people use Alpha today, from Axiomatics, Salesforce, Talis, Huawei, Rock Solid Knowledge, and then, of course, customers of some of those companies as well. And so the question is now, why Alpha 2.0? Well, Alpha is not really moving. It's not really going anywhere, and it still has a lot of the legacy of ZACWL. And what I want to do is essentially create a net new standard inspired by ZACWL, inspired by Alpha, inspired by Open Policy Agent and Rego, because there's good things in those languages, inspired by CEDAR as well, but make it a proper standard that belongs to a proper standards organization, right? So that's why the other reason is, of course, we're seeing more and more need for fine-grained authorization. If we look at past conferences like Gartner, like EIC, like Identiverse, we're hearing a lot of talk about authorization and the need to do that. If we're looking at all this stuff around zero trust, I know it's a buzzword, but definitely zero trust calls for runtime, real-time authorization. And if we have runtime, real-time authorization, we need something to back it up. I also want to promote reuse. I want to tell the other working groups here at IETF and in other organizations as well, hey guys, don't reinvent the authorization wheel. I attended one of the sessions on Monday or Tuesday on constrained devices, and they have their own language. I don't remember the RFC number, but they have their own language for authorization. What if we could bridge that to Alpha or Alpha 2.0, because then we have one single language no matter the environment you're in. And then one of the goals, not wanting to pinpoint anyone specifically, but I would like to avoid cloud platform specific solutions, not naming names. I want to simplify the existing standard. Right? Who's interested? We have a bunch of people that are interested right now in Alpha 2.0. Thanks, Peter, for reviewing the slide. The fact that people are interested even remotely doesn't mean they endorse Alpha 2.0. I want to be clear on that, right? But at least the 3 most active parties here are Huawei, Axiomatics, and Rock Solid Knowledge. We're actively working on issues to fix in Alpha 2.0. So the question to this group, I think I already know the answer because Justin and I had a chat yesterday about where it should live. So that's it. Questions?
Okay. Anybody has any thoughts, questions, comments? Justin.
Richard. It's going to stick.
Justin Richer, and I get called Richard quite a lot, and people that get my last name wrong. So just to repeat what I repeated to Dylan over here the other day. It might make sense as a work group within the IETF. That's not really for me to say. It absolutely does not make sense inside of OAuth. Right. This is a really very, very orthogonal kind of thing. It's something that if it widely existed, it would work with a bunch of OAuth tech. I do think that RAR and introspection give some really promising hooks, like I said during the last presentation, for this kind of stuff. I think that there's to me, a really clear alignment. I can also see this slotting into spaces like Whimsy and Spice, at least for the processing of Spice credentials, not necessarily work within SPICE itself. But I don't think any of those venues are the right place to do this. I will also repeat the caution that I had give Jim here. When you have an existing technology and you bring it to the IETF, it is going to get chopped up, it is going to get rearranged, it's going to get repainted, and it's going to be very, very different if you want to bring it through sort of the traditional working group process.
Right. Yeah.
So yeah, keep that in mind when you are looking for an appropriate venue for this kind of work, the kind of work that you actually want to do.
Thanks.
Jeff.
Jeff,
So I just want to be sure, because I was not sure the node was made for AWS and the CEDAR language with the avoid cloud platform proprietary options. But I just want to mention for the minutes and the record that CEDAR is not AWS technology. It's made to be used at the application layer, wherever you are based, even in your own basement if you want. It is supported by a large number of other parties which are not AWS employees. So maybe it was for some other authorization language, but not CEDAR.
Yeah, and that's actually important. Thanks.
My name is Richard, but you can call me Justin.
Hi, Justin.
Actually, Richard hit all the points I was going to hit, so plus one to what he said.
Okay. Darren.
Hey, full disclosure, I do work on CEDAR. I think it's a tricky thing because it's sort of, from one perspective, it could sound like we have so many programming languages. We have Go, we have Java, Rust. Why don't we just have one standard? And at the end of the day, if this new standard is yet another actually full-fledged implementation of a programming language with a spec and an evaluator, we should just come out and say, like, we're building a new authorization language. And then the follow-up question is, that you'll see knock on is all those other vendors that provide solutions, what stops them from piling on and calling themselves standard? And are we actually converging anything here, or are we just saying, hey, let's build another one? Which I think is probably what's going to happen. So I just wanted to share my perspective there.
Thanks, Darren.
Thanks, Darren. Johan?
Yeah, I go back, John. Do you hear me?
Yes.
And hi, David. Do you want to shed some light? What's the relation with OAUTH-Zen? Is it working parallel? Is it achieving something similar? And also, how is it connects to OAuth?
Yeah, so with regards to OAuth-Zen, they're not orthogonal, but they're parallel, I guess I'm going to say. In OAuth-Zen, in OpenID OAuth-Zen, we specifically said we would not deal with policy, because we do not want to dictate what model you're going to be using for authorization behind the scenes. We just want to provide a request response interface, both a binary yes/no request response interface, or a search interface, or a batch interface. But either way, we don't want to dictate whether you use a graph behind the scenes, an access control list behind the scenes, a policy language behind the scenes. The whole point of OAuth-Zen is actually, within OAuth-Zen, we call it to have the OAuth moment of authorization. Let me explain what I mean by that. 10, 15 years, if you bought a SaaS, you would put up with the fact that the SaaS would force you to define username and passwords within that SaaS, right? When I say SaaS, or COTS, by the way. But then at some point, because perhaps first SAML and then of course OAuth and OpenID Connect matured so much, we were in a position to tell the SaaS vendors and the COTS vendors, I will not store passwords in your system. You will have to do federation, or you will have to delegate authentication to my enterprise identity provider, right? That's what we call the OAuth moment in OAuth-Zen. And so with OAuth-Zen, we want to help authorization get there. For authorization to get there, all the authorization implementations, be it graph or policy, they need to speak the same request response format, because otherwise, why would a Salesforce switch out its authorization for a third party if they have to implement different interfaces depending on the model, OPA or ZACL or whatever else? So that's OAuth-Zen. And OAuth-Zen specifically said, we don't want to deal with the policy. Mm-hmm. It's a big, I mean, at Alpha 2.0 right now, the folks that I'm working with, yourself included, of course, we have sort of a consensus because there's so much prior art, right? If we're successful in getting a working group within IETF, maybe it's going to open up a whole bigger can of worms of people that want to introduce new features and so on and so forth. So that might actually
delay standardization, which is okay if we get to much better language. But Auth did not want to be in the middle of that because we want to create interfaces now that work, right? And in authorization, those interfaces are pretty simple. It's not as complex as OAuth flows, for instance. So that was why.
Okay. Thank you, Juan, there. I think maybe a next step for you is probably go to all dispatch. Like dispatch is a group that looks at new work that doesn't look like it fits anywhere. So and we can talk offline because I chair that group too. So okay.
Thanks for the time.
But and thanks for coming to this community. So
my pleasure.
Excellent.
Great.
Yeah. So, yeah, that's it.
And that's it. That concludes our 3 sessions. And thank you all for joining, for participation, and hope to see you in Dublin.
And thank you for the good process.
Thank you.
Progress. No, yeah.
Okay, that's good. Oh, wow. We're done. When are you flying back?